This is a relatively difficult optimization problem. In this scenario, we have a piece of sheet metal where we're folding up the two sides in order to form a gutter. In essence, we're starting off with a strip of metal like this. We're bending up the sides in order to make a gutter. The computer-drawn picture is a simplified version of that, which is highly relevant. Because if we're talking about what is the capacity of this gutter, what we're really talking about is what's the maximum area that we can enclose there, because that area just gets stretched along the gutter to form the volume, which is the capacity. One other thing we should note is what sort of values of theta make sense. If the angle was, for instance, 0, then the piece of metal would never have been bent, and we have no capacity at all. So that can't be where our maximum is. Similarly, if theta was bigger than pi halves, we once again can't possibly be getting a maximum because that wouldn't be nearly the same capacity as we would get at pi halves. So we know that the angle that we're looking for has got to be less than pi halves and bigger than 0. Like every problem along these lines, the first thing we've got to do is understand the situation. Often, it's by drawing a picture, which is what we've already done. What remains is then to find the formulas that are going to be needed, to reduce the problem somehow to a single variable, and I've given you a big hint in the drawing, and then use calculus to find the critical points. Once you've finished all that, you want to make sure that you actually answer the question that was asked, and that you check that your answer makes some sense.